So I really want to talk about spectral sequences that are cohomological so that we get that nice algebra structure. But I think as far as the sources that we have, it's going to be easier to compare those if we first talk about homological spectral sequences. So let's do that now. And let me say that some good references here are Hatcher's chapter on spectral sequences. And it's not in the book, but it's linked on the CCLE site. And I also posted Mosher and Tangora on CCLE. And here you'd want to look at their chapter 7 on spectral sequences and to begin with, exact couples. So some good reading to do. Or at least the first section of each of those. Okay, so to talk about homological spectral sequences, let's remember that we talked about first quadrant spectral sequences. So a first quadrant homology spectral sequence is going to have a bunch of pages, and on the rth page, for all r, the pq spot is going to be 0 if p is less than 0 or q is less than 0. So that's what makes it first quadrant. All the interesting stuff is concentrated in the first quadrant. And for our homology spectral sequence, our differential on the rth page goes from the pq spot to the p minus r q plus r minus 1th spot. Okay, so we say the differential has bidegree minus r comma r minus 1. Okay, so I didn't do this last time, but if we write this out carefully, then what does this start to look like? Well, I'm going to draw P on the horizontal and Q vertically. And remember, this is the first quadrant spectral sequence, so we should have zeros everywhere outside of that first quadrant. And really what I have is E1, 0, 0. E1, I guess this is the 1, 0 spot. I've got the 2, 0 spot, and so on. And then E1, 0, 1. So Q tells me the height that I'm at. E1, 1, 1. E1, 2, 1. E1, 0, 2. The E1, 1, 2 spot. The E1, 2, 2 spot, and so on. Okay, I'm already getting bored, so let's stop. But the point is that I have a bunch of abelian groups or R modules in all of these places, and really they all should be labeled separately. But somehow that's just a lot of notation and a lot to keep track of, so often what we do is draw a simplified picture here. So let me do that, much like we did last time. I'm just going to draw some dots. And those are meant to be these modules. So of course these are probably mostly different, but I just want to say that there's something there, and so I'm drawing this picture. Let me copy that to be able to use it again. Okay, so if this is our E1 page, well, again, everything is 0 outside of this. And then we should have differentials, and I guess this went off the page, so let's remember the bidegree of our differentials. So our D1 differential is on the 1th page. It should go to the left 1 and then up 0. So those look like this. This is exactly opposite from what we had in the cohomological situation, of course. And on the left edge, all of these go off to 0. So I'm not drawing those. And by abuse, I call all of these D1, but of course they're really D1 PQ or something like that for each of the PQs. Okay, when I get to the E2 page, now my differentials have a different bidegree. So what does that look like? Well, on the E2 page, let's go ahead and label that. On the E2 page, we should go to the left 2 and up 1. So our differentials have the same slope as before, but they just go the opposite direction. And of course, some of them are coming in from 0 and going out to 0. I'm not drawing those. And so on. So these are a bunch of D2 differentials. Okay, and as we keep going, these will just slant further and further up. And just like we did last time, we often will actually draw them all on the same page, which is really quite an abusive notation, but can be helpful for keeping track of our spectral sequence. So here I'll draw all the differentials at once. Now, of course, our modules change from page to page, so you have to be careful when you do this, but it can be useful. So for example, say I look at this lower right dot that I've drawn here. It supports a D1 differential and a D2 differential. Well, I guess I should say there's a possible D2 differential. Usually we reserve this statement supports a differential for when we know there's actually one there. Let's find a different color. There could be a D3 differential, so that should go over 3 and up 2. So it's going to take me over to here. And I guess I started labeling these the opposite way. So probably for the homology spectral sequence, I really should be writing D upper 1 and so on. But let me not worry too much about it. And try to find another color here. How about purple? Oops. And that wasn't a possible differential because it went over 3 and up 3. If I want a D4, then it should go over 4 and up 3. So really that should go here. I'm doing it all backwards. Okay. And that's my D4, and then I see that this spot can't support any more non-zero differentials, so the D5 will already land in the 0 range, where I have zeros, because this is a first quadrant spectral sequence. So you can see in the homology case as well, having a first quadrant spectral sequence means that all of our differentials in each spot will eventually be 0, not necessarily at the same time, but you fix a PQ, and then eventually all the differentials into it and out of it are 0. Okay, and then remember that we said that the E infinity page, well, it's going to depend on the context, but it will always be an associated graded. For a filtration of some module, usually a module that we're interested in. And the way that shows up, trying to write associated graded for some M, the way that shows up will kind of depend on the spectral sequence. So the way that I've drawn it here, it'll probably collect up things along the diagonal, but we'll get more precise about that as we get into particular examples and see what they converge to.